Good afternoon. Today we're going to be speaking about XGBoost. So what is XGBoost? XGBoost is one of the strongest classifier models out there on the market. Right now, XGBoost is known for what's called extreme gradient boosting. So this is an extreme advanced machine learning algorithm that basically furthers the concepts of what we know as gradient boosting. This is a type of ensemble learning that combines weak models to form a stronger model. The process starts with a base learner, then recalculates the errors. Then the model trains the next tree, then repeats the process. This then combines the predictions to form the final output model. XGBoost is known for its strengths in preventing overfitting due to it allowing for a learning rate. It allows for using regularization. It allows for pruning. So when we look at regularization, what that does is that adds penalty to what we know as the objective function, which actually discourages the model from becoming too complex and not allowing for the model to generalize well. So the concept of pruning is the process of removing branches from a decision tree that do not improve the model's overall performance. Right? So when we look at the comparison and we say, well, we have gradient boosting, in a previous video I've made about gradient boosting and use that as another form of a classification model. Here we have XGBoost. So what's the strong difference here? XGBoost is known for being optimized, quick. It's built with C++ as the back end. It allows for regularization, it handles missing data automatically, and it works in full parallel. So trees processing side by side, right? So with that said, one of the strongest values that XGBoost brings along with it is its ability to understand complex data sets. So when you think about classification models, what we have is kind of our base and our fundamental, or our more elementary style model will be what we know as logistic regression, where this assumes linearity between a input and an output. It assumes there's constantly an input, output linearity, right? With XGBoost, it can handle much more complications than when linearity is not visible and when it's just not there, right? So let's go through what this model is and that we are doing for our example today. So what I've got is a income data set from Kaggle where we have some attributes about different employees, their age, work class, their education, marital status, occupation. And our goal overall is to classify if they will earn above or less than or equal to 50,000. So we have, for this example, less than or equal to 50,000. Here's where we have some that are over 50,000, right? And based on the attributes of the employee or the individual, we're going to try to predict with XGBoost if they will make over 50,000. Right? So with that said, we're going to go ahead and bring in our libraries, pandas, NumPy, our XGBoost library. From scikit-learn, we're always bringing in our trained test split. We're bringing in our classification report, our confusion matrix, our ROC AUC, and our ROC curve, and then we're bringing in matplotlib as PLT. Right? So we're going to start by reading in our data set. So we're just reading this in directly into a data frame, and we can see what we have here. So again, we have our work class, education, just what our data frame brings back as what we just showed in our CSV, right? We're going to start by performing what's known as one-hot encoding on our different columns that are categorical. So work class, education, marital status, occupation, relationship, race, sex, and native country. We're going to leave this as drop first, equal to true, and then we're going to run that. And then with our binary encoding, we're going to use that by setting our predictor column. So what we're actually trying to predict. Less than or equal to 50,000, we're going to put as a 0. Greater than 50,000, we're going to give as a 1 for yes. Right? Now we can see what the data frame looks like after we perform this encoding manipulation, where we have now our work class federal government as false. Anywhere that it would be true would be a yes, right? Or how computers and how Python reads this is false is 0, true is 1, right? And so we've got our one-hot encoded columns all the way through here. You can see down to native country, which was, again, the last one that we put in here for our one-hot encoding. Right. Okay, so we're going to start by dropping our income column, so our predictor column from our features. So our X is going to be our features. We're going to drop income from our features data frame, and for Y, we're going to make it equal to the column income. For our train test split, we're going to split with 80% going to our training data set and 20% going to our test set. We're going to use stratify equal to Y in the case that there's an imbalance of our categories. So maybe there's far more over 50,000 than there are less than or equal to 50,000, right? So here's where we're going to initiate our XGBoost classifier. So we've got XGB model as our variable, and then XGB classifier. Now we've got our number of estimators, which is what we have as our number of trees. So we're going to have 300 trees. We're going to have a learning point or a learning rate of 0.05, which says for each tree we want it to contribute 0.05. Right? We want that to be the what's known as a contribution rate, but our learning rate, right? So we want it to have an influence of 0.05 essentially. Now our max depth. For each of our trees, we want them to go 4 layers deep. Now for our subsample, we want each tree to be seeing 80% at minimum of the training data set. Now we have 0.8 for our call sample by tree, and then our random state 42, use label encoder as false, and then our log loss as our eval metric. Okay, so I'm going to run that, and then we have where we're fitting our model to our train data, and then we get back essentially what that model is going to look like. So here is where we are making our predictions. So we're going to make our prediction, our model.predict on our test data set, on our X test, and then we're also going to gather our probability. Right? So we're getting our predictions, getting our probabilities, and so here we're establishing our classification report, again, that we brought in at the top, and then we're going to create a confusion matrix, and then our ROC AUC score. Right? And again, ROC AUC score, as we mentioned in previous videos, the closer to 1, the better the model. Right? It's kind of our overall AUC, ROC. This score that we're giving here allows for us to say, as an overall picture of the model, taking into account precision, recall, F1 score, what's the overall picture that we can give to this model? And our ROC AUC is the best that we can give, and say this is this is how well our model truly performs. Right? So the closer to 1, so 93 is very good. Right? We're doing very well. Now with our confusion matrix, we can see that we have a true-false, 4,672, a true-true, 1,033, and a true-false, 273, and a false-true, 535. Right? So very well, very well. Now with our precision and our recall F1 score, we're just going to go over precision. So with our precision, what our precision is telling us is that we predicted 0, 0.9, so 90% of the time accurately. For our 1, or for our over 50,000, we presented and predicted one accurately 79% of the time. Right? Now here's where we're just visualizing our ROC curve. Right? So just to see how well and how high that gets towards 1 is what we're looking for here with that curve. That's just to show us 1 is our optimal range, and we are getting right up there close to it with that 93. Right? So that's what we're looking for here. As an overall, just to recap, XGBoost is very strong of a model for being able to handle complex data sets where there's no linearity between X and Y. So X does not commonly reference to the outcome of Y. And so XGBoost is very good for this. And then also very strong for large data sets, as it has C++ as the backend, and so it can run very efficiently, very quickly. Right? So that's the end of this video. Thank you very much for joining me, and look forward to the next.